Welcome to Stellar Aerospace Universe, your hub for all things space and time. Remember to hit the subscribe button and the notification bell to stay updated with our latest content. Now let's dive into the fascinating world of wormholes. These are not physical structures as we understand them, but rather theoretical concepts born from the brain of Albert Einstein and his equations of general relativity. Imagine, if you will, a tunnel-like connection between two separate points in spacetime. This connection, or wormhole, could hypothetically allow for travel that's faster than light itself. It's akin to folding a piece of paper in half and piercing a hole through both layers, creating a direct route between 2 points that would otherwise require a longer journey. This is the magic of wormholes, a concept that has intrigued scientists and science fiction writers alike. So if we ever figure out how to navigate wormholes, we might just find ourselves taking shortcuts across the universe. But what does a wormhole look like? Well, it's not as simple as a tunnel or bridge in 3D space. In theoretical physics, wormholes are more like mathematical marvels, born from the equations of general relativity put forward by Albert Einstein. They aren't physical structures per se, but rather solutions to these equations involving the warping or folding of spacetime. Now let's dive a little deeper into this spacetime concept. In the theory of general relativity, spacetime is a four-dimensional continuum that weaves together the three dimensions of space with the fourth dimension of time. Massively heavy objects like stars or black holes can warp this spacetime fabric, creating what we perceive as gravitational effects. This brings us to the Einstein-Rosen bridge, the simplest and most elegant form of a wormhole. It's a hypothetical solution to the field equations of general relativity. Picture it as a narrow throat, or a wormhole, if you will, connecting two separate regions of spacetime. This throat presents a tantalizing possibility, a shortcut between two distant points in space and time, like a cosmic backdoor. But before you pack your bags for some intergalactic travel, remember this is all theoretical. There's no empirical evidence to support the existence of wormholes. They're a fascinating concept, an exciting area of research in theoretical physics, but their practical realization remains a heated subject of ongoing exploration and debate. So if we think of spacetime as a sheet of paper, a wormhole is like folding the paper so 2 points touch, creating a shortcut. Now that we've got a basic understanding of what a wormhole is, let's delve into some of its characteristics. When it comes to size, wormholes can vary greatly. From tiny microscopic ones to potentially massive structures, their size and shape play a crucial role in their stability. But what keeps a wormhole open? Well, here's where things get a bit science fiction-y. Theoretical physics suggests the need for something known as exotic matter, which possesses negative energy density. This exotic matter, which is yet to be observed in our universe, is hypothesized to counteract the immense gravitational pull of a wormhole, preventing it from collapsing. Now, let's talk about time travel. Some solutions to Einstein's field equations suggest that wormholes could enable time travel. They could potentially allow for what's known as closed time-like curves, essentially loops in space-time that return to the same point in space and time. But this could lead to all sorts of paradoxes, and we're not quite sure how to tackle those yet. Lastly, we come to the challenge of stability and traversability. Even if we figured out how to keep a wormhole open, it's unclear whether it would be stable enough for anything to traverse. Despite these challenges, the idea of wormholes continues to fascinate scientists and laypeople alike. Though exciting, the existence of wormholes and the possibility of traversing them remains purely speculative. Despite their theoretical nature, wormholes have found their way into our popular culture. These mysterious tunnels in spacetime have captivated our imaginations and have become a staple in the realm of science fiction. Take, for instance, the TV series Stargate, where wormholes serve as gateways to other galaxies. Or the movie Interstellar, where a wormhole near Saturn allows humans to travel to distant, potentially habitable planets. And who could forget Star Trek, where wormholes are often used for faster-than-light space travel. It's clear that while wormholes remain unproven in reality, they have certainly made their mark in the world of fiction. Thank you for joining us on this journey through the wormhole. Make sure to subscribe to Stellar Aerospace Universe and hit the notification bell to stay updated. If you have any questions or comments, drop them below. Until next time, keep looking up.